Everyone has their take-home quiz out. Someone pointed out, I think it was in this class, maybe my other class, that the wording of number 1 is incorrect. And I think they're correct on that. Anyways, it says this. A 112 kilogram football player running with a speed of 4 meters per second tackles another player. What I should have said is a football player is running with a speed of 4 meters per second, weighing 112, and they're being tackled. They're not the one tackling. They're being tackled. What impulse must the tackler give to the other player in order to bring him to a stop? It's poorly worded. I fixed it on my original. Anyways, hopefully you said, well, impulse is change in momentum. Now, there's 2 ways to calculate change in momentum. One is to go force times change in time. I don't see a change in time. I don't see a force. The other way is to realize that that's going to be final momentum minus initial momentum, because change in anything is always final minus initial, which is going to be mass v final minus mass v initial, although the final is 0 because it does say bring him to a stop. You know what the impulse is? It's going to be negative 112 times 4, which I'm pretty sure is negative 448 kilogram meters per second. 2 marks, half mark off if you left off the negative. The negative is saying that the change in momentum has to be in the opposite direction that the player is traveling, right? I have to slow him down. Number 2. What's the magnitude of the impulse needed to change the speed of a 10 kilogram body from 20 to 12 in a time of 5 seconds? Okay. Impulse is, I think it's going to be mv final minus mv initial. I think it's going to be mass 10, v final 12, careful, minus mass 10, v initial 20. Do you end up with negative 80 or negative 800? Negative 80? Here I just said tell me the magnitude, so I guess if you left the negative off, I wouldn't be able to take a mark off, but definitely to slow something down, the change in momentum has to be in the opposite direction of motion to slow it down. Otherwise, it would speed up. B says, what force is needed? Well, we also said that impulse is equal to the force over a given time. The force times a given time. So I guess the force is going to be the impulse divided by time. It's going to be negative 80 divided by 5. Is it negative 16 newtons even? Is that right or not? And the negative I'm not going to be fussy on because I implied in the first question that I was only interested in magnitude. What's the negative saying here? The force needs to be in the opposite direction of motion. So that negative is a vector. You're not losing 16 newtons. It's saying 16 newtons, but if you're traveling that way, you better point it that way. So far, so good? A cart of mass 3.2 kilograms traveling 1.2 meters per second collides with a stationary... Did I say collision? This is a job for conservation of momentum. Unless they're asking me something about force or time or impulse. Nope, I read the question. So I'm going to start out by saying this. The sum of all the momentum before the collision equals the sum of all the momentum after the collision. Before the collision, what's moving? Mass 1, mass 2, or both? I think mass 1. So I'm going to have momentum 1 initial. Wham! They collide. After the, oh, come on, you've missed that. Happy New Year! After the collision, what's moving? Mass 1, mass 2, or both? That was well timed, by the way. I got the moment of silence. That was really well done. Both. Stuck together or separate? Stuck together. Fancy word for stuck together. Who remembers? Inelastic. It's inelastic. By the way, I wish it was non-elastic because anelastic collision and inelastic collision sound so much alike. Non is a clearer syllable, but I'm not in charge of what they label these things. Anyways, so it's going to be momentum both final. And then I said from now on, we're also going to ask, hey, are there any angles, any norths of souths, any east of, any thetas? No, everything's in a nice straight line. Then we can just do straight algebra. But if not, then we went to our DALP, draw little arrows, do a very careful vector diagram, and you noticed when there was angles raised, the level of difficulty jumped exponentially. It got way more challenging. But to me, those are way more interesting too. It's going to be M1 V1 initial equals M1 plus M2 V final. I guess V final is going to be M1 V1 initial divided by M1 plus M2. Again, if this was at angles, I couldn't do any of these steps. That would be garbage, and I'd have to give you 0 for the rest of your work. I'd probably give you 2 out of 7. So again, make sure you're looking for, your next quiz is going to have lots of angles. Make sure you're looking. If there's angles, it gets much more challenging. But here, I think it's going to be Mass 1, 3.2, 1.2, all over 3.2 plus 1.8. What do you get? You know what? I think I can do this in my head, actually. Because there's a 5 on the bottom, dividing by 5. No. What do you get? It's going to be slower than 1.2. I know that. Because the objects are going to slow down after the collision. 0.768. Anybody else? I said speed, not velocity. If I'd said velocity, well, I didn't give you directions. I guess you'd say in the original direction or something like that. Okay. In terms of part marks, I can't remember how I did this one. Momentum. Quiz 1, version 1, answers. I think this is it. I didn't do part marks. Maybe I did part marks in this version here. Let's see, because that looks like a newer one. Didn't do part marks. Maybe I did part marks in this one here. No, good gosh. You know what? Probably 1 mark for that, 1 mark for that, 1 mark for that, and then 1 mark for the answer. Something like that. Turn the page. Oh, that was it? Not turn the page. So can you give yourself a lovely score out of, count 'em? Oh, that's the wrong one. Can you give yourself a lovely score out of, count 'em, 10? And can you pass them inwards, please? Make sure your name is on them. So don't forget the bonus video game. Last day. Holy smokes. We kicked it up a notch. We looked at lesson 6, two-dimensional, holy smokes, two-dimensional momentum. There was a bit of a mix-up because I'd forgotten or I, for some reason, didn't have actual practice questions attached. But who was away last day and doesn't have a copy of lesson 6, which is the key lesson in the unit? So I called this lesson 6.5, more two-dimensional momentum. Okay. What I did is I went through old provincial exams and I stole some questions. So, a 3,300 kilogram truck traveling at 18 meters per second, about 40 miles an hour, in the direction of 35 degrees north of east, collides with a stationary 1,600 kilogram car. After the collision, the car has a speed of 15 meters per second due east. What's the resulting velocity of the truck? Is this a collision? This is a job for momentum. Also, do I notice directions and angles? Then before I go any further, because I've got this wrong before, north, east, south, west. All right. William, I said this is a collision. This is a job for conservation of momentum. So I start out the same as one-dimensional momentum. I want to be in a nice familiar zone, Bree, so I want to kind of have an approach that I can modify for 2 dimensions, but I like to start out in the shallow end or the familiar area of the pool. The sum of all the momentum beforehand equals the sum of all the momentum after. And I gave you the whole page, the whole half page for this, yeah? Okay. Before the collision, what's moving? The truck, the car, or both? The truck? You know what? I'll use T for truck and C for car instead of 1 and 2 since that works well. So I'm going to go like this then. Momentum of truck initial, it's a vector. Wham! They collide. After the collision, what's moving? The truck, the car, or both? I think both. Stuck together or separate? Why wouldn't they be stuck together? What's this question asking me to find? The velocity of the truck. If they were stuck together, wouldn't the velocity of the truck be 15 meters per second due east? And this would be kind of a stupid question. Right? It'd be the same as the car. So I can infer, I can reasonably assume separate. Momentum car final plus momentum truck final. And those of you that were away for lesson 6, you'll notice so far nothing different. But now, who was here? What was our strategy now? Now what did we do? Dolp. We're going to draw vectors very carefully. And I've tried to leave space so that I can draw an arrow underneath here, an arrow underneath here, an arrow underneath here. Let's do the truck initial. What direction? The truck initial, what direction? Okay, north of east, so I'm going to go like this. East. North of east, 35 degrees. So this is 35 degrees. How big is that arrow? The momentum goes there. What's the momentum? Mass times velocity. So what's going to go on that arrow there? 59400. Most common mistake I see, kids want to put velocities on here. They want to say that velocity is conserved. No, 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 no. Momentum, mass times velocity is conserved. And so each arrow gets labeled with mass times velocity. They collide. What's the final direction of the car? East. How big? Mass times velocity of the car. What's mass times velocity of the car final? 24,000 even? Plus, don't know. That's what they're asking me to find. How could I find the question mark? How could I get the question mark by itself? Michael, what?
Minus the 24,000.
I'm going to subtract a vector. I'm going to subtract a vector. How do I subtract vectors? I don't. What do I do instead? In fact, you know what I should have done, I think, Curtis? What I should have really done is this. I should have said, this is going to be truck initial, takeaway, car final. That's going to give me truck final. Okay? I think this is what I can use, except now I'm going to go like this. Right? Add the opposite. Add the opposite. So I think I can draw a vector triangle. My vector triangle, this plus this, tip to tail, is going to give me my final truck. You okay with me, Neve? This is tough. So, truck addition, you know what? I'm going to draw this thing. Now I'm going to be a bit more accurate. I'm going to try and draw it roughly to scale. What I mean by that, Elijah, this is 60,000. This is 25,000, roughly about half as long. I'll try and draw this line about half as long, roughly. So let's draw the truck initial first. It's going to look like this. Come on, pen. Yeah. Where this is 59,400. What am I adding to that? What am I adding to that? 24,000 west. Yeah. I think the final momentum of the truck is going to be that there. I need an angle inside the triangle. Wait a minute. How big is that angle right there? 35 degrees. Can we see a Z? How big is that angle right there? Okay. So I can say this is SOHCAHTOA, right angle trig? No, you know what? It's going to be the cosine law. How do you know? Well, first of all, because, trust me, it's almost always the cosine law. Oh, because there's no pair. I don't know both of those. I don't know both of those. I don't know both of those. Yeah. Okay. What squared equals what squared plus what squared minus 2, what, cos what? That's the cosine law. Oh, what am I trying to find, Nate? So it's going to be, that's not the color that I wanted. Momentum truck final squared, and that's going to be the first one squared plus the second one squared minus 2 times the first one times the second one cosine of the angle. What's the final momentum of the truck? $24,000 squared plus 59,400 squared minus 2 times 24,000. That didn't work, Mr. Dueck. 24,000 times 59,400 cos 35. Yeah, but how did I get an even answer? Oh, there's decimals, it's just not showing them. I hope. Do you get 42057? No? Yeah? So I'll go 42057. That's to 5 sig figs. That's pretty good. Carrying extra sig figs because I'm going to use this. Units, it's momentum, so it would be kilogram meters per second. It's not what they asked me to find. That's the final momentum. What did this question want me to find? What is this question asking me to find? Is it asking me to find final momentum? Oh, velocity. How can I get a velocity if I know momentum? Divide by the mass, okay? There's a lot of steps here. Divide by the mass. So, velocity of truck final is going to be 42057 divided by, what was the mass of the truck? 3,300 kilograms? Do you get 12.744, 12.7? Now, if instead of saying find the velocity, if they had just said find the speed, I'm done. Or if they had said find the final kinetic energy of the truck, now I could go a half mv squared. I don't need to find theta if they had said, Alex, find the speed or find the kinetic energy, some kind of a scalar component. And I think on your test, probably, certainly on the multiple choice, you can expect, Callum, one question or two where I just say, find the speed. Because there's still a lot more work to do, and I figure if you can get this far, you're probably pretty good. On the written, almost certainly at least once, I'll say find the velocity, probably twice. Did this question say find the speed, though? It said find the velocity. That means, Kelly, I need an angle, I need a theta. At. At what? Well, to be honest, the angle that I want is that one. Because that would be north of east, I think. Yes? Problem. The angle that I can find is this little one right here. That's a terrible theta. Is this little one right here. Oh, you know what? If I find theta and then add 35 degrees to it, then I think, Peter, that'll give me a good north of east. You with me okay? Okay? This is a bit of a tricky one because, well, my truck's in a weird location. You okay with that though, Jordan? We'll find little theta here, and then if we add 35, that'll give us the big bright yellow north of east. Yeah? You sure? Because you're not looking, yeah? Okay, you just looked out of it. How can I find theta? This is a job for the sine law. The sine of 35 over what's across from it equals the sine of mystery angle theta over what's across from it, 24,000. Cross multiply, get the sine theta by itself. In fact, I think we'll get this. Sine theta is going to end up being 24,000 sine 35 divided by 42,057 point whatever. 24,000 sine 35 divided by 42057.03, if I even want to be a bit more accurate. And then shift sine of that to get the actual angle. Do you get 19.1 degrees? But that doesn't mean I'm going to put 19.1 degrees right there. I need to add 35 to it. It's going to be 54.1 degrees north of east. There's my final answer. Which way does the truck move off after this collision? It moves off at 12.7 meters per second at an angle of 54.1 degrees north of east. Okay. It's about as tough as I'll throw at you because this was a yucky angle to find as well. And I didn't give you a picture. I made you figure it all out. Probably on your test I'll give you a picture. Example 2. A 2 kilogram mass moving at 4 meters per second north hits a stationary 6 kilogram mass. The collision takes 0.025 seconds. After the collision, the 2 kilogram mass is moving at 3.8 meters per second and 10 degrees west of north. A, find the final speed and direction of the 6 kilogram mass. B, draw a vector diagram showing initial and final momenta. I think I'm going to do part B in order to find part A anyhow, so I'll kind of do them simultaneously. C, find the force. Oh, yeah, I guess if I know the, I'll have to figure out the change in moment. Yeah, I can do this. I can do this. Okay. Okay. Is there a collision? This is a job for conservation of momentum. Also, because I've turned the page, you guys probably haven't, but I'm going to go north, east, south, west. The sum of all the momentum before the collision equals the sum of all the momentum after the collision. Before the collision, what's moving? Mass 1, mass 2, or both? The 2 kilogram mass is moving. So we have momentum 1 initial. Wham, they collide. After the collision, what's moving? Mass 1, mass 2, or both? Both. Stuck together or separate? I think separate. Otherwise, this would kind of be a silly question if they wanted speed and direction and they were stuck together because they told me speed and direction of the two. So, momentum 1 final plus momentum 2 final. Dolp. North. Yoink. Right? How big? 2 kilograms, 4 meters per second. That equals 8. Momentum 1 final. 10 degrees west of north. So it's going to be go north first. Go 10 degrees west of north. And how big? 3.8 times 2. 3.8 times 2. 7.6? You know what, Aaron? Again, we could subtract. Although, so we had this one last time, and we subtracted to find the mystery. We added the opposite. I wonder if we can just kind of visualize what the triangle must look like. In other words, put your pencils down for a second. Here's my 7.6 at an angle of 10 degrees. I want to add to that something so that I get a resultant like that. can you see what the missing vector must, I think the missing vector has to be something like that. Is that okay? So you can do the subtraction method like we just did, or you might be able to, Sam, just kind of visualize what the triangle has to look like for it to work. It's up to you. I could have done the same thing here. I could have said, you know what? If I'm supposed to end up going that way, this plus what? Well, I think this plus that will give me, it's up to you. The previous question, I think, was tougher to visualize. But does that make sense? If I want to finish with, if I want to add those two vectors together, Bree, if I want these two to add together to give me 8 pointing straight up, and one of them is pointing to the left, I think the other one's got to be pointing to the right. Probably up. Maybe it's pointing down, but I think, well, no, actually, because 8 is bigger than 7.6, I'm pretty sure it's pointing up. So draw that. Oh, and we'll call that momentum 2 final. The only thing I don't like is my diagram's a little small. Ha-ha! There you go. And let's move it up a little bit. There. Let's make that 10 degrees a bit more legible. Sine law? Cos law? Cos law. Definitely not SOHCAHTOA. It's going to be momentum 2 final squared equals 8 squared plus 7.6 squared minus 2 times 8 times 7.6 cosine of 10 degrees. Eight squared plus 7.6 squared minus 2 times 8 times 7.6 times the cos of 10. Oh! Square root. 1.416, I'll go 1.41682. Again, carrying extra sig figs because I'm going to use this because, Michael, they didn't ask me to find the final momentum. What did they ask me to find in part A? Okay. V2 final. How can I get a speed from there? You're right, I think. Which mass? Mass number, the 6, yeah? Divide by the 6. 0.236. So I'll just write in my work 1.41682 divided by 6 is 0.236 meters per second. That's the speed. Did they say direction as well? No. Ugh. Ugh. Why is this one yucky? Don't write this down. Don't write this down. Why won't that angle help? Or will it?
There's no other angles referred to.
It's not a north of east, south of west. It's a slanty next to a slanty, which means it's not going to help me much at all. Why will that angle help? What letter do you see there? Okay, you know what? This is what we can write down. I'm going to find that angle there is theta. It's the same as that top right corner angle, except this angle isn't. It's next to it's going to be something of north, isn't east of north? That'll work. That'll work. So let's find. Let's see. It's going to be sine theta over 7.6. Equals the sine of 10 over 1.4162. Right? Right. Sine theta equals 7.6 sine 10 all over 1.4162. 7.6 sine 10 all over 1.41682. Shift sine of that. 68.7 degrees. East of north. That looks like a W, Mr. Dueck. Is that what the answer says, I hope? 21.3 degrees north of east. That is 68.7 degrees east of north. Same angle. Same, depending which way you start. Woohoo! So I've done A, and in doing A, I did B. I drew a vector diagram. What does C want me to find? Curtis, what does part C want me to find? Find the force on the 2 kilogram mass. Well, that's going to be its change in momentum. Right? I don't think we're going to have quite enough room to finish this, but I'm not going to freak out. Part C. Force change in time equals change in momentum. I think the force is going to be the change in momentum divided by the time. Which is going to be final minus initial. Oh, not changing, Mr. Dueck. Problem. Is my initial momentum of the 2 kilogram mass 0? No. Is the final momentum of the 2 kilogram mass 0? No. Are they nice and in the same direction? No. Peter, you know what we have to do here? We have to subtract vectors by drawing them. Oh, I don't. I add the opposite. This is going to be yucky. A lot of work. However, hey, what's Newton's third law? I'll give you a hint. Newton's second is F equals ma. Newton's first is objects at rest tend to remain at rest. Objects in motion tend to remain in motion. The law of inertia. What? Forces come in pairs. What's this question asking me to find, by the way? A force? Yeah. I'm going to find the force on the 6 kilogram mass, because the magnitude will be the same. Now, why is that nice? What's the initial momentum of the 6 kilogram mass? Come on, what's the initial momentum of the 6 kilogram mass? 0. It's going to be way easier. Oh, but the direction, Nate, the direction, I'll take that for the 2 kilogram mass. You with me? Is that okay?
Yeah.
I'm not going to give you one this tough. But the fact that one of them has a momentum of 0, forces come in pairs, even though the masses are different. They both experience the same magnitude of force, opposite direction, but magnitude of force. So it seems to me I can say this: 0 minus, or sorry, what's the final momentum? The final momentum of mass of the 6 kilogram mass was what did we say? Of the 6 kilogram mass was 1.41682. Come on, pen. 1.41682 minus 0 all over how much time? Because the time of collision, Kelly, has got to be the same for both of them, right? What was the time, Kelly? I've scrolled down. 0.025? So in terms of force in newtons, is the answer I have up there, does it say 56.7 newtons? I hope. Yeah? Direction, you know what? In the opposite direction that the 6 kilogram mass gained momentum. So what direction did the 6 kilogram mass gain momentum? 68.7 degrees east of north. That means the 2 kilogram mass lost momentum 68.7 degrees west of south. William, had we actually gone final minus initial for mass 2 and done the vector subtraction, we would have got the same answer. But the fact that, because I know, Elijah, forces come in pairs, and I could get a 0 in my equation by actually finding the force on the other one, oh, let's do that. And then we'll just toggle the direction, because we know, oh, if the 6 kilogram mass gained momentum that way, the 2 kilogram mass must have lost momentum in the opposite direction, because momentum is conserved. Is that okay? That is a review of what we missed. What's your homework? I don't have an answer yet for number 1. I didn't do an answer key. And when I started typing this up, I wasn't leaving you room to do this on the sheet, but it looks like I left you room for the other ones. If you can fit number 1 on the sheet, great, or on a piece of paper, and we'll confirm what the answer is next class. Number 2, I did do an answer key for. Number 3, I did do an answer for. Number 3, all I asked you for was the speed. Didn't bother finding the direction. Number 4, the multiple choice. 5, good, I did do the answer for. And 6, 7, and 8. Lots of practice. These are all old provincial exam questions. Welcome back.